This is the protocol reference table you must have memorized before you walk into the exam. Not because memorizing port numbers is inherently interesting, but because the exam tests them directly. And in production environments, you need them to write the correct firewall rules that allow your automation tools to reach their targets. Let's walk the entire table together so the associations stick. DNS, Domain Name System, runs on port 53, primarily UDP, but TCP for responses that exceed 512 bytes, or for zone transfers. Every single API call your Python script makes begins with a DNS lookup to resolve the host name, like devicesinbox.cisco.com, to an IP address. If DNS is broken, nothing else works. Your request.get call will time out before it even sends a packet to the target device. NTP, Network Time Protocol, runs on port 123 UDP. Time synchronization sounds mundane, but it's critical for two specific automation reasons. First, TLS certificate validation requires that the device's clock be within a few minutes of accurate time. If the clock is off, HTTPS connections will fail with certificate errors because the cert appears to be either expired or not yet valid. Second, log timestamps from multiple devices only correlate correctly when every device agrees on the time. If device A says 10 hours, 00 minutes, and 01 seconds, and device B says 10 hours, 07 minutes, and 43 seconds, your incident timeline is garbage. SNMP, Simple Network Management Protocol, uses two separate ports, and you need to keep them straight. Port 161 UDP is for polling. Your management station sends a GET or GET bulk request to the agent on the device, and the device responds. Port 162 UDP is for traps. The device initiates and sends an unsolicited notification to your SNMP collector when something notable happens. A link goes down, a threshold is exceeded. Always use SNMP version 3 in production. It adds both authentication and encryption. SNP v1 and v2c send community strings in plain text. SSH, Secure Shell, is port 22 TCP. It's your encrypted remote management channel, the transport for SFTP file transfers, and the underlying protocol for netconf sessions. Speaking of netcon, the network configuration protocol that carries Yang model device configuration, it runs over SSH but on port 830 specifically, not 22. That's a dedicated port for netcon, and it's an exam favorite. HTTP is port 80 TCP. HTTPS is port 443 TCP. Every production REST API call goes over HTTPS on 443. Always. HTTP is unencrypted and you should never send API credentials over it. FTP uses two TCP ports, port 21 for the control channel where commands are sent, and port 20 for the data channel where file content actually flows. FTP sends everything in clear text, credentials and data both. So avoid it in any security-conscious environment. Instead, use SFTP SSH file transfer protocol, which piggybacks on the SSH connection on port 22 and encrypts everything. Finally, SMTP Simple Mail Transfer Protocol is port 25 or 587 TCP. Automation scripts commonly send email alerts via SMTP when a monitored threshold is crossed or a deployment fails. Know all 8 protocols in this table. DNS53 and TP123, SNMP 161 and 162, netconf 830. HTTP 80, HTTPS 443, FTP 2021, SFTP 22S, NTP 25 over 587. TCP versus UDP, this is a foundational exam question that appears on virtually every Cisco certification at every level. So let's make absolutely sure it's locked in with enough context that you can reason through any scenario, not just recall a memorized answer. TCP stands for Transmission Control Protocol, and it's connection-oriented. Before a single byte of real application data moves, TCP executes a three-way handshake between the two endpoints. Your client sends a SYN, short for synchronize, segment to the server. The server replies with a SYN ACK, meaning it acknowledged your SYN and is sending its own synchronize. Your client sends a final ACK, acknowledgement, and now you have an established TCP connection with both sides synchronized on sequence numbers. From this point forward, every segment is acknowledged. If the receiving side doesn't send back an ACK within a timeout window, the sender retransmits the segment. TCP also implements flow control. The receiver advertises a window size that tells the sender how much data it can accept without being overwhelmed. The price for all this reliability is overhead. The three-way handshake adds latency before any data flows, and the continuous ACK traffic consumes bandwidth. For HTTP, HTTPS, SSH, SMTP, FTP, and SFTP, any protocol where losing data is unacceptable, TCP's overhead is worth the cost. UDP stands for User Datagram Protocol, and it's connectionless. There is no handshake. The sender creates a datagram and fires it toward the destination without waiting to confirm it arrived, without sequencing, and without any retransmission mechanism. That sounds reckless, but for the right use case, it's exactly right. Consider DNS. You send a single packet query asking what IP address maps to a hostname. You expect a single packet answer within milliseconds. Running a three-way TCP handshake before each DNS query would add more latency than the lookup itself. If the UDP query doesn't come back, the client simply retransmits the question. The application handles the retry, not the transport layer. NTP is the same logic. Frequent small-time update packets where low latency and minimal overhead matter far more than guaranteed delivery. SNMP polling and traps are UDP for the same reason. High frequencies, small messages where the management application can handle loss. For your automation scripts, every REST API call travels over HTTPS, which is TCP port 443. Your Python request library depends on a successful TCP connection. When a firewall blocks port 443 to a device, your requests.get call will hang until the connection timeout expires, and then raise a requests.exceptions. Connection error. Understanding that the transport is TCP, the port is 443, and a firewall ACL is the likely culprit tells you exactly where to start debugging. And that's the practical payoff of knowing these fundamentals.